Welcome to another Pre-Calculus 20 lesson. Today we're going to look at some special triangles that help us simplify a lot of our Pythagorean theorem calculations and make things a lot quicker and easier for us. So we'll be looking at the 45-45-90 triangle and the 30-60-90 triangle as well. So we use Pythagorean theorem to solve right triangles, and right triangles only. They have to have a 90-degree angle within them in order to use the theorem of Pythagoras. So those are pretty poor, but you get the point. We're going to use Pythagorean theorem to solve these four triangles, and actually we're going to use it to solve two of the four and then make some simplifications to solve the other two. So the first one, we have side A, side B, and side C, we'll call it. So we go 1 squared plus 1 squared equals x squared. So this is 1 plus 1, which is 2, equals x squared, and x equals root 2. Okay, so that was pretty quick. Now, I guess we'll hash this out and then I'll show you how it could easily have been simplified. Give you a little preview. Each of these sides are 1. Each of these sides is 3 times the length of this side. So let's see what happens when we use our Pythagorean theorem to find the side length of x. So we get 3 squared plus 3 squared is 9 plus 9 is x squared. 18 is x squared, which means that x is root 18, and root 18 can be written as the root of 9 times 2, and we know that the root of 9 is 3, so this can be written as 3 root 2. Now you notice when we multiplied each side length by 3, the hypotenuse also ended up getting multiplied by 3. So here it was root 2, 1, 1, root 2. Here it was 3, 3, and then 3 root 2. So whatever you have for your side lengths in a 45-45-90 triangle, you can multiply by root 2 to find your hypotenuse. Simple as that. Alright, so here we have a 30-60-90 triangle. Since this is 90 degrees, we know that this has to be 60 because they add up to 180, all three of them together. And here we have a side and we have the hypotenuse, so we have A and C. So we go 1 squared plus x squared in this case, which will represent your side B, equals 2 squared. So 1 plus x squared equals 4, x squared equals 3, subtract 1 from both sides, and x equals root 3. Okay, so that's root 3. Now, you can see here 1 and 2, the hypotenuse in a 30-60-90 triangle is always double the shortest leg. So on this one, we have our shortest leg, which is 3, and our hypotenuse is double that. Now, this leg is a little bit longer, and again, we can probably predict what it's going to be because when it was 1 and 2, we multiplied them by 3 to get 3 and 6. And this one was root 3, so we're going to go ahead and make a prediction that we multiply that by 3 as well. And let's see if this ends up working out. So we have 3 squared plus x squared equals 6 squared. 9 plus x squared equals 36. And x squared equals 36 minus 9. 36 minus 9 is 27. X equals root 27. And I'm going to rewrite 27 as 9 times 3. And then x equals the root of 9 is 3. And root 3 is left under the radical sign. So again, you multiply the legs by 3. And you multiply the hypotenuse by 3. So if you know any one of these legs and know that it's a 30-60-90 triangle, you can solve for the other two, making some simplifications, and save yourself a lot of time by not using Pythagorean theorem. Just write in the values that you already know. fill in the primary trigonometric ratio definitions below. Sine theta, we know that is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. And tan theta is opposite over adjacent. So katoa. Okay, nothing new there. We're just going to go ahead and skip this part. It's not super relevant to what we're doing, but let's go down and look at our 45, 45, 90 triangle here. And this 45, 45, 90 triangle, 45, 45, 90 triangle, it's also technically called an isosceles right triangle. Okay. And that's basically all we were doing with this, was showing that this would be an isosceles triangle if P equals Q. And this is a special type of isosceles triangle where the other angle is 90 degrees. What two sides of triangle PQR have equal lengths? It would be QR, and then not the hypotenuse, but side PR here. So QR would have an equal length to PR. QR equals 1 unit long. Find the lengths of the two remaining sides. This is really quick based on what we just did. PR has the same length, and then PQ or QP from the last page that we did would be root 2. From your results above, determine these ratios. Sine of 45, now we know that sine of 45 is opposite over adjacent. So it doesn't matter if we go here or if we go here. The values are going to be the same because opposite and adjacent are equivalent to each other. And sorry, sine is opposite over hypotenuse, not adjacent. So sine of 45 would be 1 of the legs, over the hypotenuse, which is root 2. Cos 45 would be 1, which is one of the two legs, over the hypotenuse, which is root 2. Tan 45 would be opposite over adjacent, which would be both of the two legs, which would be 1 over 1, which is obviously 1. Now, tangents can also be described as a sine divided by a cos, which is rise over run, which is the slope of the hypotenuse. Okay? So in a 45, 45, 90 triangle, the slope of the hypotenuse is exactly 1 because its rise is equal to its run. And you can see here, if you divided sine by cos, 1 over root 2 divided by 1 over root 2, anything divided by itself is 1, and that would confirm that that is true. Now a 30, 60, 90 triangle, let's consider these two triangles here. 3 triangles, or 4 triangles, I guess, if you want to be technical about it. Find the size of each angle in ABC. Okay, this one's 60, this one's 90, which means using our sum 180 rule, this has to be 30. If this one is 90, this whole line is 180, then this obviously has to be 90. This is 30, this is 30, this is 60, and those should all be accompanied with a unit. Don't catch me being lazy. So that's 30 degrees, 30 degrees, 60 degrees. Okay, B. That was B. C. Find the size of each angle in ABD. Oh, okay, so that was C as well. Done. Find the size of each side in ABD. Now, we could use Pythagorean theorem, we could use trig ratios, and take up a lot of time doing all that stuff, but as I told you on the last one, on the first page, In a 30, 60, 90 triangle, the hypotenuse is always double the shortest leg. So here our shortest leg is 1, which means the hypotenuse is 2. And this one then is going to be root 3. So if this is 1, this is 2, this is 2, and then the length of this common side is root 3. So pretty quick, pretty simple. Use your results from number 6 above to determine the exact values of the primary ratios for 60 degrees. So sine of 60 is opposite over hypotenuse. So since we're looking at specifically the 60-degree angle, this one has to be the opposite side. It can't be this one. So it's opposite over hypotenuse, and this one ends up being root 3 over 2. Cos of 60 is adjacent over hypotenuse. So cos of 60 is 1/2. Tan of 60 is opposite over adjacent, which is root 3 over 1. Okay, which you could also have found by doing sine over cos. Tangent equals sine over cos, equals rise over run, equals, root 3 over 2 is sine, divided by 1 over 2, okay? And when you divide by a fraction, you multiply by its reciprocal, so we multiply root 3 over 2 by 2 over 1 instead, so we just flipped this. And then when you do that, the 2's cancel, and you see you get root 3 over 1, which of course is just root 3. We don't need to write divides by 1 because it doesn't change anything. Alright, now sine of 30 degrees. Now here's a little trick. They just flip because they use all the same sides, and I'll show you what I mean in a second. Cos 60 degrees was 1 over 2. Sine 30 degrees is 1 over 2. So these trade. Sine 60 is root 3 over 2. Cos 30 is root 3 over 2. Alright? Now let's see if that's true based on the triangles we drew. Sine 30 is opposite over hypotenuse. So you look at our 30-degree angle, we go opposite, 1, over hypotenuse, 2. So sine 30 should be 1/2. Got it. You can confirm that that's true for the cos 30 as well. Tan 30 is just the reciprocal of this. So this would be 1 over root 3. So let's look at practical example or 2. An 8-meter boom is used to move a bundle of piping from point A to point B. Determine the exact horizontal displacement of the end of the boom when the operator raises it from 30 to 60 degrees. Okay, now in a 30-60 triangle, the short side in this triangle is the one with the 60-degree angle here, and it is always half the hypotenuse. So that's just 4 meters right here, okay? Now, if that's 4 meters, then this one is 4 root 3. Now, that won't really become too relevant to us because we're only looking for the horizontal displacement. So how far it moved to get from here to here, or from here to here, I guess is the order that it goes in. Alright, now I'll do different color, and let's look at the other triangle, which was the boom's starting position. This one is still 8 meters, and this one is 4 meters because it is now the short side where this is the 60-degree angle. And which means this, the red length here, the whole horizontal length, will be 4 times root 3. So the difference between the two positions is the long one minus the short one. So 4 root 3 minus 4. And that is your horizontal displacement. Now if you wanted to turn that into a decimal number, you just punch in root 3 on your calculator. It's an irrational number, and it gives you 1.7321, and it would keep going. We'll round it off there. and then you multiply that by 4, gives you 6.9282. Okay, and then subtract 4, and of course you get 2.9282. 2.9282. So that is the horizontal displacement, and of course we need a unit, and that would be meters. Okay. Similar type of question here. A metronome is used to help piano students keep time while practicing. The pendulum arm of the metronome is 10 centimeters long. So this is the pendulum arm, 10 centimeters. 10 centimeters. So it swings like that. And we want to know if the metronome tempo is adjusted so that the pendulum swings from 45 degrees to 135 degrees, what exact horizontal displacement does the tip of the pendulum arm travel in one beat? So this is the distance we're looking for, and it goes from 45 degrees, which is this angle, to 135, which will be this big angle that goes all the way from here to here. Okay, so that's 135. Now, the difference between these two angles will be what you get in the middle here, and it turns out that 135 minus 45 degrees is, of course, 90 degrees. 90 degrees in here. So, if these two arms are equal, and this is 90 degrees, that means these two angles have to be equal as well. So we are looking at a 45, 45, 90 triangle here. So x will be really quick to figure out. A normal 45, 45, 90 triangle is 1, 1, root 2. Sorry for my awful triangle. And this time we multiply each of these by 10. Okay, so there you go. Then this value x equals 10 root 2. And this will be in centimeters. All right. And again, if you want to put an actual number on it, you won't get an exact value because root 2 is irrational, but root 2 times 10 will give you 14.14 centimeters. So that's how far that tip travels. All right. That's it. See you in class tomorrow.